Hello viewers, Wagadaruna taking you through the story for A-Level Math Contest Practice. And this video, we are going to go through the solutions to the NMC. NMC means National Math Contest Assignments 1, 2, 3 for day 1. The video for day 1 is already on the platform, so if you have just joined, I encourage you to first watch the video for day 1, which is on Algebraic Foundations. Then you can, after that, you can proceed with this video which has the solutions to the assignments which were left in video 1. So video for day 1. In video day 1, we left 3 assignments, and those are the ones we are going to go through. I believe that you tried them out and now you are ready to find out what went wrong. Before we begin, like I've always done, allow me to first remind you of the books which I personally recommend. So for O-Level, there are 4 books we recommend. For math, there is Math Volume 1 of 2, which contains Senior 1 and Senior 2 work, and the item bank, which is complete, Senior 1 to 4. Then for Physics, for it is already complete. The notes are right from Senior 1 to Senior 4. Even the item bank is from Senior 1 to Senior 4. So if you're in O-Level at any class, I encourage you to access these books. And if you want them, call on this one of those contacts. For A-Level, there are a number of books. There is Math 1, Math 2, and the item bank for pure math. Then there is Physics 1, Physics 2, and the item bank for Physics 2. That means that there are 2 pending item banks for A-Level and also 1 book for O-Level, which is Math Senior 3 and Senior 4. We shall complete them with time. So if you need any of those copies, call on this number. I encourage you to call because there are some people who are funny. Do you know what they do? They remove the book cover and they just they get the old editions and they attach a new cover having this edition 2026. So you'll buy thinking you have bought at the latest edition, yet actually you're buying a very old edition. So not all books on market are original. Some of them are duplicate. So that's why I encourage you to call so that you can be directed to where genuine books can be got. So with that, we shall now go through the solution. So question 1 was saying that given that xy is greater than, the product of x times y is greater than 0. In other words, the product of x and y is positive. That's what it means. And that x minus y is equal to x times y. Okay? Find the value of this. So meaning that you have to use these 2 conditions to come up with the value of that. The first thing to do, we shall try to combine these 2. I think you realize that here there was 120, 120, so we factorize it out. Now we're going to combine these 2 into 1 LCM. I think that's what we said under rational expressions in video 1. So when I combine this into 1 LCM, I'll come up with this. Then you realize that here we have x minus y equal to xy. Yet here we have y minus x. So y minus x will be equal to what? To be negative of xy. That's why you're saying here negative of xy. Then this one, because then here we realize this and this can cancel. When it cancels, you remain with the negative 1. Negative 1 times 120, that's where this negative 120 came from. Plus 2022 to give you 1902 as the required value. So basically that was the trick behind this question. Then question 2 says, let this be equal to this, okay? What is the value of x over y? So we are given that for us to get x over y being the denominator, we have to introduce an innocent expression. So multiply both numerator and denominator by 1 over y. In other words, we divide by y, both up and down. When we do that, we shall come up with this, and this gives you x over y, and here, this and this gives you 1, this and this gives you x over y, this and this gives you 1. So if we let a to be equal to x over y, it means that we shall come and get a minus 1 over a plus 1 is equal to this. Cross multiply, you come up with that. And when I correct like terms, bring this one this side, you come up with 1a. Bring this one this side, you come up with 4049. Therefore, the value of x over y will be equal to 4049. And basically, that's what they wanted in that question. And now shall go to question 3. Question 3 says that given that this is equal to this and this is equal to this, determine the value of x, y. So if I begin with this equation, I'll first rearrange and then I square both sides. Squaring both sides, this gives you this x plus y squared, and this gives you x plus root xy squared. Expand this using the identity, expand this using the identity, you come up with those values. The next is to rearrange here, correct like terms. Here there is 2xy, here there is xy. So when I bring this one this side, I'll come up with just xy. When I do that, you realize something. This one is exactly the same as this. And they told us it's equal to 84, meaning that now I can substitute. So where there was the whole of this, I've put there 84. Then I can now bring this side to come up with 48 equal to 12 square root of xy. Divide both sides by 12 to come up with that. Then to remove the square root, I square both sides to come up with 16 as the answer. So basically, that is what they wanted in question 3. Question 4 says, suppose that x and y are two real numbers such that x minus y is equal to 2 and x squared plus y squared equal to 8. Find the value of x cubed minus y cubed. So from this, when I square both sides, I'll come up with x minus y squared equal to 2 squared. Then expand this, I'll come up with this. Here it will be 4. But we realize that this x squared plus y squared is equal to 8, yet here I also have x squared plus y squared. So the whole of this will be equal to 8. When I take this one this side, I come up with 2xy. Bring this one this side, I come up with 4. Then xy will be equal to 2. So now I have xy. Also from this one, when I cube it, I can come up with this. This is an identity, hope you know it. X cubed minus y cubed minus 3xy in brackets x minus y. It is equal to 8. Now substituting for xy and x minus y, I'll come up with xy is 2, x minus y is 2, and it's equal to 8. So that means that I can make this the subject. And that is what they wanted. So basically, you have to understand the structure of the equations given and how to deal with them to get the required output. Then question 5 says, if x is equal to 2 plus root 3, find the integer or fraction equal to x power 4 plus x 1 over x power 4. So when x is this, then x plus 1 over x, I will replace x, put there this, 1 over x, I'll come up with this. When I rationalize that, I'll come up with this, because rationalizing means 1 over 2 plus root 3 multiplied by 2 minus root 3, even here, 2 minus root 3. Here, denominator, you realize that this becomes difference of 2 squares, which is 4 minus 3 to give you 1. So in the end, we'll come up with 2 minus root 3 over 1. That's why you're seeing 2 minus root 3 there. After that, you realize that this and this can cancel to come up with 2 plus 2, which is equal to 4. So basically, x plus 1 over x is equal to 4. But remember, they want x power 4 plus 1 over x power 4. So now when we go to squared, x squared plus 1 over x squared is the same as using the identity. It will be x plus 1 over x. Now we're using the identity which says that a squared plus b squared is equal to a plus b squared minus 2ab. In this case, our a is x, our b is 1 over x. So here, when we add, we come up with x plus 1 over x squared minus 2 times x times 1 over x. Now, x times 1 over x gives you 1. That is why you're just seeing here 2, like that. Then we substitute. We already know this value. It is here, which is 4. Meaning I'll come up with 4 squared minus 2 to give me 14. Okay. When I know that, I'll remember that this one can be written as, because here in this case it means that x squared plus 1 over x squared, like that. So it takes, we are using the same identity of a squared plus b squared equal to a plus b minus 2ab. The difference now in this case, our a is equal to x squared and our b is equal to x squared, meaning that a squared will be, b is equal to 1 over x squared, meaning that a squared will now become x power 4, like that. So when you use that, we shall come here to be now x squared plus 1 over x squared minus 2 times a, which is x squared, times b, which is 1 over x squared. You realize that now this and this cancels to remain with x squared plus 1 over x squared minus 2, which is now here. And the good thing, we know the value of this is 14, so I'll come and substitute for 14 here, squared minus 2 to give me the answer they wanted. So basically, that is how you could do question 5. Now for question 6 says, suppose that a is greater than 0. In other words, a is positive. If a is positive, and if this minus this plus this is equal to 0, okay, find the reciprocal of a half plus x power a. So required value is this reciprocal means 1 over this. So get LCM. LCM will be 2, so it will be 1 over, in brackets, 2, 1 plus 2x power a. then these two can come up. That's why you're saying here 2 over 1 plus 2x power a. Now from this given equation, we need to use it to get this expression. Okay. So rearranging gives you that. What I've done, I've brought this for this side to come up with this. Then square both sides to come up with. So when I square, this squared gives you x power a. Then 2 times this to give you this middle term. Then also this square to give you 16x power negative a. 14 squared is 16. So there I realize that this and this can cancel because it is the same as x power a over 2 times 1 over x power a over 2. Like that. If not, you can use same base, you add the powers to give you power 0. Like this also works. So 2 times 4 will be 8. That's why you're seeing 8 there. So x power a plus 16 over x power a will be equal to 8. When I multiply that by x power a, I'll come up with this, which gives me a quadratic in x power a. So here, when I use a calculator, now this one is the same as, for example, if, okay, another one could say that let y be equal to x power a. In that case, I would say y squared minus 8y plus 16 is equal to 0. Then I realize that the value of y will be equal to 4. But y is x power a, so that's where this is coming from. This is a quadratic in x power a. Therefore, required value will be, remember it was 2 over 1 plus 2 times x power a to give you that as the answer. So basically, that is what they wanted in question 6. Question 7, it says, let a, b, and c be real numbers such that this plus this plus this is equal to 0. Okay. Find the value of a plus b plus c. So now that takes us to the core rules of algebra, the ones I talked about in day 1. I told you that here, in algebra, we don't expand blindly. Don't expand blindly. You expand when you are sure that it will help. You expand when you are sure that it will help. So in this case, this question, you don't need to expand. What you need to do is to remember that the smallest value of an even power is always 0. So if anything raised to the uneven power must be greater than or equal to 0. Now, if this is equal to 0, it means that this was supposed to be 0, 0, 0, like that. When that is known, it means that you shall equate each to 0. So here it was supposed to be right-hand side, because this is left. Left-hand side will be equal to 0. Left-hand side will be equal to 0. That is true. Only if each squared term is equal to 0. So when this is equal to 0, you come up with a equals 6. When this is equal to 0, you'll come up with b equal to 4. And when this is equal to 0, you'll come up with c equal to 5. Then you can add to get the value they want. As simple as that. So you didn't have to expand. If you began your solution by expanding, then that was the wrong approach. That was the wrong approach. So basically, that is how assignment 1 was. Now we shall go to assignment 2. Question 1 of assignment 2 says, what is the value of this? So the powers look a little big, but we can use factorization to reduce them. So, for example, if here you realize of these two, the smallest power is 2012. That's what we can factorize out. So this 2014 is the same as 2012 plus 2. 2014 is the same as 2012 plus 2 to give you this. Meaning that now I can factorize out 2 to the power 2012, both numerator and denominator. So this can cancel. Here I realize that here I remain with 5 and here I remain with 3, which gives you 5 over 3 as the answer. As simple as that. So you didn't need to the bigger powers were not supposed to scare you. Then question 2 says, evaluate the following expression. This. Evaluate, we shall not need to use a calculator because if you get a calculator and punch, then it is not okay. So how do we do that? One, we shall say let the base be equal to this, be equal to 20x. Therefore, the required value now becomes, this one becomes x, then 2026 be the same as x power x plus 1. This one alone, when you expand, you come up with this. Using the identities now. I'm not now using the identities. Here, how did we do it? To expand that, because there are 3, we made this one. We first took this as a one term to give you now, and we used this expression. So in this case, it means that our A is x squared. Our B is 2x plus 1. So A squared becomes x to the power 4. B squared becomes 2x plus 1 squared, which is this. Then the middle term becomes 2 times x squared times 2x plus 1, which is that. So that's how we can use identities to expand such. Then from there, I can now open this bracket to come up with this. In the end, I come up with that. Therefore, the required value now, I've put this one here, replace this with this. And also now I can expand this to give you this. It's a non-identity. Then I will see if some terms can be collected. You realize that there is 2, 1, 1 here. There is x power 4, x power 4 there. Here even down there is this and this. There is also this and this. So I can collect like terms. Let's collect like terms and we see. When I collect like terms, I come up with this. Then I realize that here 2 is common in all, so I can factorize it out. Also, 2 is common here, so I can factorize it out. Then I'll remain with that. Now here now I cannot use synthetic division. So the base is long division. When I long divide, this will be the polynomial. This will be the divisor. So divisor is here. Then I put the polynomial inside here. How do we long divide? Like we did yesterday, we said we deal with high powers. So this divide by this. X power 4 over x squared. You remain with x power 2. That's what you write up here. So I'll come and write x power 2. Then that x to power 2, you multiply it by the whole divisor to come up with x power 4, x cubed plus x squared. You subtract and we see what we are left with. When you subtract, this goes away. Then this minus this gives you x squared, x cubed. This minus this gives you 2x squared. This minus 0, 2x, this minus 0, 1. So when I divide this by this, I come up with 1x, which is there. Repeat the procedure, multiply this one by the whole of this, you come up with this. Subtract to see what you are left with. you'll be left with x squared plus 1 plus x plus 1. Then divide, still do the same. This divide by this, you come up with 1. 1 times the whole of this, you come up with that. When you subtract, we get 0 as the remainder. So that means that this one, when you divide this, we get this, which is now here. After that, remember what we said about x. X is 2025, so 2025 here, 2025 here, to come up with this as the answer. So basically, that's how you could do it without using a calculator. Same applies to the next question also. They only changed the year from 2025 to 2011, but all the powers were the same, meaning that we still go through the same procedure. So we shall not need to repeat the procedure since it's the same as the one in question 3. So what we shall do, we shall just rewrite. We already know that when we divide this, we come up with this. So we should just call it because the procedure is still the same. Then we can substitute for x and get the answer they want. Then question 4 says, given that x plus 1 over x is equal to negative 1, determine the value of x power 88 plus 1 over x power 88. Here there is something we need to know, the pattern. Remember we told you in Math Olympiad, strong algebra will lead you to writing very long solutions. What we need is you to discover the structure. So there's something you will realize that if I have x plus 1 over x and I multiply it with x power n plus 1 over x power n, I'll come up, when I open brackets, let's open x times x power n, you get this. X times 1 over x power n, you get this. 1 over x plus times this, you get this. Then this times this, you get this. Then from there, if we try to rearrange, you're going to realize that this, we are going to pair now symmetrical. So this and this gives this bracket. This and this gives this bracket. What does that mean? It means that if Sn represents x power n, sorry, Sn represents x power n plus 1 over x power n, it implies that this one now becomes s power n plus 1, this one s power n minus 1, this one s power n, like that. This one, if you want, you can write it as s1 because the power is 1. So with that, it means that we can now come and substitute. The whole of this, we know it is negative 1. So put your negative 1 there. Okay. This is s power sn. This is Sn plus 1. This is Sn minus 1. Then make this the subject. I'll come up with this. What we want to do, we want to find out the pattern because this power is too much. I think you remember in the previous assignment, they had given us x power 4 plus 1 over x power 4. That could, and we did it in bits step by step. We first got to 1 over x plus 1 over x, then we went to x squared plus 1 over x squared. Okay, then we went to x power 4 plus 1 over x power 4. Now, if you use this procedure, by the time we reach x power 88, it will be too many steps. That is why we had to first get the logic behind. We have to first get the logic behind. So always s to power n plus 1 is always will be equal to negative, in brackets, Sn plus Sn minus 1, provided x plus 1 over x is equal to negative 1. After knowing that, we shall now say that, first of all, S1 is negative 1. We know that. So that means that when n is 1, here it should be S2, negative, in brackets, S1 plus S0. So we need S0. S0 means when the power is 0. And we all know that this and this any number at power 0 is 1, so 1 plus 1 gives you 2. So in short, S0 is 2. When we use those 2, we shall now be able to get S. So in short, when getting the value of this, will be equal to S88. So we have to get S88. Let's see how. So S2 will be equal to negative of S1 plus S0 to give you substitute. Substitute for S1, substitute for S0, come up with negative 1. Go to S3. S3 means here it is S2 and S1 to give you this. Do the same to S3, so S4, S5. So now you realize that S2 is negative 1, S0 is 2, negative 1, negative 1, 2, negative 1, negative 1. Let's see the next. The next is 2. Now, because the next is 2, it means that there is a pattern we should have identified. Because we began with 2, negative 1, negative 1. Then we went to 2, negative 1, negative 1, 2. Like that. So meaning that there is a pattern. The pattern is that it keeps repeating after every 3 terms. After every 3 terms. So if you begin with 1, so negative 1, negative 1, 2. Negative 1, negative 1, 2. So even the next will be negative 1, negative 1, 2. Negative 1, negative 1, 2, like that. So that means that there is a pattern. There is a pattern. So we shall say that the sequence is periodic with a period of 3. Period of 3 means that after every 3 terms, there is a repetition. After these 3, there's a repetition. After every 3, there is a repetition. That's what we mean by period. Okay, so then we realize that because it has a period 3, we shall use modulo 3. Modulo 3, anyway, the word modulo is under number theory, modular arithmetic. I think I'll need to get time and also brief you something about modular arithmetic, but it's mainly about dealing with remainders. Dealing with remainders. For example, when they give you, when they say 3 divide by 3, what will you get? I'll get one whole number, remainder 0. Now, in modulo, our interest is this remainder, like that. Our interest is this remainder. You realize that S3, the remainder is 0. That's why you say that when n is 3, the remainder is 0. Like that. Same applies to this. Yeah, that is 3. Here it was supposed to be 4, 5, 6. Still 6. If I divide 6 divided by 3, I'll get 2, remainder 0. Now, how do we write that in terms of modulo? We shall say 6 is equivalent to 0 modulo 3. Meaning that when I divide 6 by 3, I must get a remainder of 0. So you get 2 when this n is divisible by 3. And you can get negative 1 when the remainder is 1 or remainder is 2. That's what they mean. For example, 5, when I say 5 divided by 3, I'll get 1, remainder 2. When I say 4 divided by 3, 1, remainder 1. So when the remainder is 1 or 2, the answer should give you negative 1. That's what they are trying to mean. So that means that now if I want to get 88, when I say 88 divide by 3, what do we get? Let me first press calculate and we see. So 88 divided by 3, I get the whole number is 29. So I'll say 29 remainder. What will be the remainder? So remainder, I will say remainder will be 1. So it will be 29 remainder 1. That is why you are seeing me here writing that 88 is equivalent to 1 modulo 3, like that. And here we said 1 lies here of negative 1, meaning that S88 will be equal to negative 1. So we shall teach modular arithmetics. The only challenge is that modular arithmetics is under number theory, yet we are still on algebra, and I don't want to confuse you. So if what I've given you about modulo is still wanting, I encourage you to first pause. You can just write this solution, then keep it so that when we are under number theory and we learn modular arithmetics, you can easily go back and understand what it really meant. Then question 5 says, without using a calculator, okay, what integer is equal to the square root of 2000 times 2008 times 2009 times 2017 plus 1296? So let's begin with that part A. Let r, we shall let r be equal to this square root. So here, when we square both sides, we'll come up with that. So realize that 1296 will be equal to 36 squared. So let's try to see. So if I write 1296 and I want to prime factorize it, depending on the calculator I have, if you have this type fx991es plus, then plus c, then it can do this. So you just press shift, factorize. Then that means that this one will be equal to 2 to the power 4 times 3 to the power 4, which gives you 6 to the power 4. But the 6 to the power 4 is the same as 6 to the power 2 like that, which gives you 36 squared, like that. Then bring this one this side, you come up with this. Okay? Then from there, I'll say that let A be equal to 2000. Then I'll substitute. So this will be now 2008, 2009, 2017. And so will be 2000. This will be difference of 2 squares to give you this. Then here I'm going to rearrange this with this, gives you this. Then this and this gives me this. When I bring this A inside, I'll come up with this. Then when I combine these two, I'll come up with 17A. So this 72 is the same as 36 plus 36. Okay. So what I'm going to do, I'm going to let x be equal to a squared plus 17a plus 36 here. I can replace it here. When I do that, I'm trying to get something this side, which is equal to this side. You realize that we come up with this one because this one is x, then plus 36. Then this one, it means that if x is equal to a squared plus 17 plus 17a, actually here there is an a missing here, 17a plus 36. Then when I bring this 36 this side, I come up with x minus 36 equal to a squared plus 17a, like that. So here there is an a missing here. When I multiply this one inside, there's an a there, there's an a there, to give you x minus 36. So that means that if you look at these two things, you realize that r will be equal to x. So I can conclude that r is equal to x, meaning that because x is this, even r is equal to that. And the good thing, we already know the value of a is 2000. So I'm going to substitute for a to get the value of r. And remember at the beginning, our r was the required square root. So that means that the value they wanted is that. That was part A. Now let's go to part B. Part B says if 1.00005 zeros, then 42376 squared is equal to this. What is the value of x plus y plus z? So you need to get the value, the digits x, y, and z. Okay. So left-hand side is equal to this, which can be written as this. And when I expand this using the identity, I think remember the identity a plus b squared is equal to a squared plus 2ab, which is the middle term, plus b squared. So our a is 1. So a squared is here, 1. Then 2ab, 2 times 1 times this gives you this. Then plus this squared, like that. Okay. But this one is too small to affect the first 3 non-zero digits. That was the assumption, the reasoning we wanted. That was the reasoning we wanted, meaning that therefore, this one can be equal to this, which is this. And when I multiply 2 with this, I'll come up with this. I think here you can, because I don't want to use the calculator, you can just know that when I multiply 2 by this is 12, so 2 power 1, carry 1, then 2 times this is 14, plus 1 is 15, so this is 15, 5 carry 1, like that. Then we'll come up with these digits. Then when we compare, you realize that now the first 3 non-zero digits are 8, 4, 7. Therefore, the sum they want is 19. And that's what they wanted. So basically, we are interested in your analytical reasoning. Analytical reasoning. Question 6 says, without using a calculator, evaluate this. Okay? So what you're going to do, we shall let this be equal to A. And let this be equal to B. That means that now the whole expression they want is A minus B. Like that. So if I remove this root, it means that the cube root, it means that I have to cube both sides. So A cubed will be equal to this, what is inside the cube root. Then also B cubed will be equal to what is inside the cube root. So required value is A minus B, because this is A, this is B. So how do we get that A minus B? The good thing, we know A cubed and we also know B cubed. So we can start from there. We can start from there by saying what A minus B cubed will be equal to A cubed minus B cubed minus 3AB minus A minus B. That is an identity. That is an identity. So equation 1 minus equation 2. I'll be able to, but my aim is to get this value. So it will be this. Let me first simplify that before I substitute in equation 3. So when I simplify, I'll come up with this, because realize that this and this can cancel. So I'm going to remain with 10 minus negative 5, 45 minus negative 5, which is 10. Okay. And remember here we have our A cubed minus B cubed, don't forget. Then equation 1 times equation 2, what if I multiply the 2, I come up with this, open brackets. When I open brackets, it will be difference of 2 squares. This squared minus this squared to give you that 27, meaning that AB is cube root of 27 gives you 3. So AB is that. Why are we trying to do that? Because we want to get these ones. Our aim is to get A minus B. So I had to get AB. I also had to get this. And now that I have got them, I can now substitute to come up with that. Simplify. Then this gives us a cubic equation in terms of A minus B. If you want to see it, you can say let x be equal to A minus B, then substitute here to become now x cubed plus 9x minus 10 equal to 0. Then we can test. How do we test? We test using factors of those of 10. Remember, 10 can be 10 and 1. It can be 2 and 5. So that means that if you are testing, you must test using plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, like that. If I use positive 1, I'll come up with 0 equal to 0, meaning that the x equal to 1 is a root. When it is a root, I can now use synthetic division to divide. And I think, like I told you in the previous video, we write coefficients of the polynomial. Coefficients are 1, x squared is not there, so we put 0, then 9, and negative 10. Then we bring this one down. Then multiply this by this to give you what is here. After that, we repeat the procedure. This plus this is 1. 1 times this gives you 1. Then this plus this gives you 10. 10 times this gives you 10. This plus this is 0. And we said what is here is called a remainder. So if you have not yet watched the first video of algebraic foundations, I encourage you to first watch it. So that means that now this has been factorized to give you this. So when I solve the quadratic, I'll come up with that. So there are no real roots for x, meaning that the only real root is x equal to 1. And remember we said x was a minus b, and a minus b is what they wanted. So indirectly, we have got the required value. So brings us the end of assignment 2. Now we shall go to assignment 3. Question 1 of assignment 3 says, the non-zero numbers a, b, c, x, y, and z are such that this is true. Determine the value of this. Okay. So one shall start with a given condition. This all are equal, so let them be equal to a certain constant k. It therefore implies that when I say x over a equal to k, it implies that x is equal to ka, which is here. When I say y over b is equal to k, it implies that y is equal to kb. When I say z over c is equal to k, it implies that z is equal to kc. So that is what this line means. Okay, then after that, I'll now go to the required value. And then I substitute for x, y, and z. When I substitute for x, y, and z, I'll come up with that expression, x here, y here, and z here. Then also down there is x plus y, which is that, y plus z, and z plus x. Okay. After that, I'll need something will cancel if you analyze. 1, ABC will cancel. Okay. 2. 2, let me see what else cancels. Do you see this a plus b and this? They cancel. Do you see b plus c? They cancel. Do you see c plus a? They cancel. Then also, you realize that this k times a is k cubed. And you see k cubed here? So everything keeps cancelling until you remain with 1. And that's what they wanted. Then question 2 says, given that this is equal to this and this is equal to this, find the value of d over a. So d over a, here we have a over a b plus c plus d. We need to look for a way of getting d over a. So 1, a over b plus c is 3 over 5, meaning the reciprocal becomes b plus c over a, which is 5 over 3. Okay? Then from there, we can also get the reciprocal. Then that reciprocal, this one, I can split the numerator, this over a, this over a. Then I'll remember that this is 5 over 3. So come and substitute, put it here. Then take now this one the other side to get what they wanted. As simple as that. So basically, that's what they wanted in question 2. Question 3 says, let ABC be Pythagorean triples. Triples means they fulfill a right angle triangle. I think you know if 1 is 3, 4, this should be 5. Why? Because 5 squared will be equal to 3 squared plus 4 squared. That's what they mean by Pythagorean triples. The 3 sides of a right angle triangle. The triplet are positive integers. Note this word integers. Integers means we don't have decimal places. I can't get to 1.2. It is either 1, 3, 1, 2, 3, or negatives, or 0, like that. Prove that this is greater than 8. Okay. So let's begin by expanding it using the identity. This squared, then plus the middle term, which is 2 times this, then this squared to give you that. After that, next is to remember that because a plus b plus c squared is equal to c squared, it means that I can come and replace this c throughout c squared with a squared plus b squared. Let's do that. So this one gives you this one gives you this, and this gives you that. After that, I will now split the numerator. So this over this is 1, which is here. This over this is this. This one, let me first leave it there. Then here split, this gives you this, and this gives you 1. So 1 and 1 is 2. This one remains, and these 2 also remain. So when I write this in terms of sum and product, it becomes, difference and product. I think remember that was also an identity that a squared plus b squared is equal to a minus b squared plus 2ab. If I can also write it as this, like that. But because we are interested in positive values, let's use minus. So now this means that I can also split this numerator. Even here, that's what I've used. There I've used difference and product to give you this. So it still follows the same identity, that a squared plus b squared is a minus b squared plus 2ab. This is our a, our b. Then here it is 2ab, like that. So that means that I come up with this. So here I've combined into one LCM to give you that. Then here, what we have done, we have just collected like terms, this plus this plus this to give you 8. Okay. And you realize that the rest are squared terms. This is squared, and also all these ones are bigger than 0 because they said they are positive. Okay. And remember we said that the smallest value of a squared term is always 0. Smallest value of a squared term is always 0. Since we already have 8 plus some value, it will always be greater than or equal to 8, like that. In short, we shall have proved that it is greater than 8 because it is already 8 here, and we have some other non-negative values. Non-negative values. Then question 4 says, if this is equal to that and this is equal to this, compute this as a fraction of integers. So they want a fraction. So required value is that, combine into one LCM. Always we need to combine into one LCM. Then collect like terms, this and this gives you -2. Expand this to give you this. Okay, then from that given two equations with two unknowns, we need to get the value of this and this because that's what they want. That's what we need for us to get the required value. We need x plus y and also we need xy. So we shall get them from these two equations. Therefore, from the first one, combine into one LCM, you will come up with xy is equal to 2x plus y. Okay. Then from the second equation, combine into one LCM, open, expand. Then we substitute for xy. Remember we say they told us that xy is equal to 2 in brackets x plus y. So substitute for this to give you this. Then you realize that now we have that. Cross multiply to give you that. We want the value of x plus y. So x plus y is 13. When x plus y is 13, it means that now we can get the value of xy because xy is twice x plus y, which is 26. Once we know the sum and product, we can now get the required value. So required value will be 13 minus 2 over 26 because this was x plus y, this was xy. So in the end, we shall come up with 11 over 14 as the required value. And that's what they wanted. Then question 5 says, prove that if A, B, and C are distinct real numbers such that this is equal to 0, then this is also equal to 0. Okay. So one, you realize that we have what they want here, these are squared. But here we don't have squared. That's actually the only difference. So what we are going to do, we shall multiply both sides of this by 1 over b minus c plus this, which is here. So that we can easily get these squares. We can easily get those squares. So innocent expressions are chosen wisely. We don't just guess. We have to look at the structure, then we find out what to do. After doing that, let me expand. So this with this gives me this one. This with this gives me this. This with this gives me that. That is the first term up to here. Then go the next. This with this gives me this. This with this gives me this. This with this gives me this. That is second. Then the third one, this with this gives you this, this with this gives you this, this with this gives you that. Okay. Now, if you look at it, in our expansion, we already have this. There is this, and there is this. That is the reason. Mean that you have to look for a way of making all the rest, this, we have to look for removing them, so they should be equal to 0 actually in short terms. We are going so this, we have seen this. Now what else? We are going to realize something. Let me see. Do you see? Let's look at the denominators now. Denominators, I have C minus A, B minus C. C minus A, B minus C. Isn't it? That means that I'm going to get now A plus B, C minus A, B minus C. Then also I have, here it is A minus B, B minus C. Let me see which other. It is here. A minus B, B minus C. So I'll get also plus A plus C over A minus B, B minus C. Okay. Then what else? The other one is this one, A minus B, C minus A. A minus B, C minus A. So it is B plus C, A minus C. Then is it A minus C? It is A minus B, A minus B, C minus A. Like that. So in short, I have added all the terms. So let's write that in the next slide. That is what we have so far. Now, I want to deal with this one to see how it goes away. So let me first leave these ones alone because they're already in the required expression. Now let me combine this into one fraction. LCM will be the product, this, and this. Then we divide this one with this. What cancels? This goes, and remain with this and this. That's why you're seeing here this. Same applies to this other one. You remain with this. For this one, you remain with this. In all, you realize that there is difference of 2 squares, I think. Difference of 2 squares here. Difference of 2 squares, A squared minus B squared here. Difference of 2 squares, C squared minus A squared here. Difference of 2 squares, B squared minus C squared. Okay, then let's see what cancels. This goes with this. This goes with this. Okay, this goes with this. Everything has gone out, so meaning that it is now 0. 0 divided by any number, we still get 0. So we'll come up with this, whereby this is 0, and therefore you'll have got the required proof. So basically, that's what they wanted in that question. So that brings us to the end of this video. Thank you for watching, and bear in mind the next video will be now on day 2 training, which is cyclic and symmetric algebra. So if you have not yet subscribed, please click on the subscribe button below this video. And also, if you know any student who's not yet on this platform, please share the link of this video via social media platforms like TikTok and WhatsApp, so that can all benefit us, a family.